Clue number 1. The universe has a resolution limit. In any high-definition video game, if you zoom in far enough on an object, you eventually hit a limit. You see the individual pixels. The smooth, continuous image breaks down into a grid of discrete units. You cannot zoom in forever. This limit is fundamental to the digital world. What if our physical world has the exact same property? Well, it appears that it does. In the early 20th century, physicist Max Planck discovered a fundamental limit to the fabric of space-time. It's called the Planck length. It is an unimaginably small distance, trillions of times smaller than an atom, but it is not zero. It's a real physical value, 1.6 times 10 to the power of minus 35 meters. According to our current understanding of physics, it is physically meaningless to talk about any distance smaller than the Planck length. It is the cosmic pixel. It is the point at which the very concept of space and distance breaks down. Just like a pixel on a screen, you cannot have half a pixel. Our smooth, continuous reality seems to be built upon a foundation of these discrete, indivisible units. Why should reality have a minimum resolution? A truly fundamental base reality shouldn't need one, but a simulated reality would absolutely require one. Computational resources are never infinite. A simulation must be built on finite units to be calculable. The existence of the Planck length is not definitive proof, but it is a fascinating and uncanny echo of how any digital system must be constructed. Clue number 2. The universe is written in the language of mathematics. The physicist Eugene Wigner once wrote about the unreasonable effectiveness of mathematics in the natural sciences. And he was right. It is truly bizarre how perfectly the universe obeys mathematical laws. From the elegant curve of a planet's orbit, described by calculus, to the chaotic dance of subatomic particles, governed by the probabilistic equations of quantum mechanics. It's all mathematics. It didn't have to be this way. The universe could have been a chaotic, lawless place with no discernible order. Instead, it seems to operate on a set of rigid, underlying rules that can be discovered, written down, and used to make astonishingly accurate predictions. These rules are universal. The law of gravity works the same way in your kitchen as it does in a galaxy billions of light years away. Physicist Max Tegmark of MIT takes this idea a step further with his mathematical universe hypothesis. He argues that the universe isn't just described by mathematics. It is mathematics. Our reality is a vast, complex mathematical structure. This sounds strange, but think about a simulated world in a computer game. What is it, fundamentally? It's a structure of pure mathematics. The game's physics engine, its lighting system, its artificial intelligence, it's all code, all algorithms, all math. The reality experienced by a character inside that game would be, at its core, a mathematical one. So when we look out at the cosmos and see that its fundamental operating principles are all elegant equations, we have to ask, are we simply discovering the laws of nature? Or are we reverse engineering the source code of our own simulation? Clue number 3. The universe has glitches and unexplained phenomena. Every complex software system has bugs, unintended behaviors, performance issues, or parts of the code that are not fully optimized. If our universe is a simulation, it might be the most complex software ever created, and it might have its own share of cosmic glitches. Consider dark matter. It makes up about 27% of the universe, and we have absolutely no idea what it is. We can't see it. We can't touch it. It doesn't interact with light or any form of ordinary matter. We only know it exists because of its gravitational effects on galaxies. It's like an invisible scaffold holding the cosmos together. From a simulation perspective, dark matter could be a computational shortcut, a piece of simplified, placeholder code designed to produce the correct gravitational effects without needing to render the complex details of actual matter, thus saving immense processing power. Then there is dark energy. This is even stranger. It makes up 68% of the universe and is causing the expansion of the universe to accelerate. This was a complete shock to scientists when it was discovered. It's as if a fundamental parameter of the system was suddenly changed. In programming terms, this could be the result of a system update or an unforeseen consequence of the simulation running for billions of years, a bug that emerged from the system's own complexity. Even at the quantum level, things like quantum entanglement, what Einstein called spooky action at a distance, behave less like physical objects and more like information being processed in a non-local way, instantly connecting two data points, regardless of their distance. Are these true mysteries of nature, or are they the artifacts of a system we were never meant to look at this closely? Clue number 4, the universal speed limit. Nothing in the universe can travel faster than the speed of light in a vacuum. Nothing. It is the absolute, unbreakable speed limit of the cosmos. But why should there be a speed limit at all? In a base reality, it's not obvious why such a rigid restriction should exist. But in a computed reality, it makes perfect sense. Think of it as the processor speed of the universe's computer. Every computer processor has a clock speed, a maximum rate at which it can perform calculations. This limits how fast information can be processed and rendered within the system. The speed of light in our universe functions in a remarkably similar way. It is the maximum speed at which information, at which cause and effect, can travel from one point to another. It is the refresh rate of reality. The existence of this finite, constant speed limit prevents paradoxes and ensures the simulation's code remains consistent and stable. It sets the maximum processing power for the entire system. Once again, a fundamental law of our physics looks suspiciously like a necessary feature for a stable, simulated environment. Clue number 5, reality doesn't exist until we look at it. This is perhaps the most mind-bending clue of all, and it comes from the heart of quantum mechanics. It's called the observer effect. Experiments have shown, time and time again, that at the subatomic level, particles behave differently when they are being measured or observed. The famous double-slit experiment demonstrates this perfectly. Fire a particle like an electron at a screen with two slits, and if you don't watch which slit it goes through, it behaves like a wave, passing through both slits at once. But the moment you place a detector to see which slit it goes through, its behavior changes. It chooses a single path and acts like a solid particle. It's as if the universe knew it was being watched and only then decided to make up its mind. This is bizarre. Why would the act of observation change physical reality? Let's go back to our video game analogy. To save processing power, a game doesn't render the entire game world in full detail all at once. It only renders what's in the player's field of view. The city block behind you might exist as a simple set of data, but its detailed textures, its lighting, the people walking there, they are only fully rendered when you turn around to look. It's a resource management strategy. Could our universe be doing the same thing? Could it be that reality only exists in a definite state when a conscious observer is there to measure it, to render it? To save on the unimaginable computational resources required to simulate an entire universe down to every last atom, the system only renders reality in full detail when and where it is needed. This idea that consciousness itself is required to collapse a wave of probabilities into a concrete reality is one of the deepest and most disturbing implications of quantum physics. And it aligns perfectly with how an efficient, resource-managing simulation would be designed. Music shifts to a more conclusive, reflective tone. So, where does this leave us? A pixelated reality, a universe built on pure mathematics, cosmic glitches, a universal processing speed, and a world that only seems to exist when we are looking at it. It's important to be clear, none of these clues are definitive proof. They are interpretations, analogies. There are counter-arguments. Some ask, if we are in a simulation, who is running it? And are they in a simulation too? Creating a turtles all the way down paradox. But the evidence is tantalizing, and the implications are staggering. If we do live in a simulation, is there a purpose to it? Are we an experiment, a piece of entertainment? Or have we, the simulated beings, become so complex that we are now looking back at the code that created us? Perhaps the ultimate truth is that we will never know for sure. But the quest for that truth, the act of questioning the very nature of our reality, is what drives science forward. It is the echo of infinity calling to us from the deepest layers of the cosmos. What do you think? Are these just strange coincidences of physics, or are they profound clues to the true nature of our existence? Let us know your thoughts in the comments below. And if you want to continue exploring the biggest questions of the universe, be sure to subscribe to Echoes of Infinity. Thank you for watching.